hope all of us are doing great. My name is Ernest, and this Ernest is Sciences and Mathematics TV channel. So in this specific discussion, I'm going to look at the physical interpretation of the concept of Helmholtz free energy function and the Gibbs free energy function. Now, in our last discussion, I had mentioned about these two specific functions, and we said that we can be able to represent the Gibbs free energy function as that specific representation for G, and then we said that we can be able to we can represent the Helmholtz free energy function as also as a function given as a. So in this specific case, we had discussed that these two particular functions are going to be employed in determining the spontaneity and the equilibrium of various transformations. And of course, we said that these are going to be an extra, or rather an extra criterion for determining this specific aspect of spontaneity and equilibrium, apart from the Lecce theory principle and equilibrium constant that we had seen in various other applications. So in this particular case, there were two specific equations that we had given for representation of Helmholtz free energy and Gibbs free energy, and we said that this is going to consist of variables which are going to be regarded as thermodynamic variables, which are basically state functions. And of course, as we said, these are going to be state functions which are going to be independent of the various parts or the processes which are going to occur in between, of course, as we had said. So in this case, the Helmholtz free energy was given as the difference between internal energy, the product of the absolute temperature and entropy. And we said that we can illustrate the Gibbs free energy using enthalpy minus the product of absolute temperature and of course the entropy given as such. And this therefore assisted us to use these specific variables in trying to explain the appreciable change perhaps in temperature, and that of course led us to a specific equation that, or two specific equations that we used to represent the two specific functions using this concept of an appreciable change in temperature. So therefore, we had given a representation for change in Helmholtz free energy as delta A, which was delta E, basically implying the change in internal energy minus T delta S given as such. And the change in Gibbs free energy had been represented using delta H, which is a change in enthalpy. And then we had delta Ts given in this particular case, and we had considered a case whereby, of course, this specific temperature anisothermal change. So we had delta H, and this is a T delta S given as such. So those are the two specific representations that we have given, representing the Helmholtz energy and the Gibbs free energy in that specific order. And the combination of the two, of course, trying to look at this specific change, their similarities. And therefore, that led us to have a general representation of this specific equation for constant temperature and pressure, which gave the overall relationship of the Gibbs free energy given as a sum of Helmholtz energy and then P delta V. Now, this last part of the second element of this specific equation for equation number 3, which was our last interpretation of those specific functions for free energy and maximum work. In this specific case, of course, we're going to see that from the first law of thermodynamics, we have given this specific element as an element of work, which is going to be interpreted basically as the work of expansion that is going to be performed in this specific case, in considering temperature in isothermal, or in that particular case for an expansion process. Therefore, we are going to look at the implication, the physical implications of this specific aspect of delta A and delta G. And of course, that's going to create for us a clearer difference between the two. Now, we have mentioned that for a thermodynamically reversible process that is taking place at constant temperature, there's going to be increase in this specific aspect of entropy. And therefore, we said that entropy can be regarded as a measure or the degree of disorder. Therefore, an increase in temperature is going to lead to the aspect of a disorder. And of course, the decrease in temperature is going to lead to a reverse process, or the reverse process of that one is going to be having a true implication of the increase in order in that specific respect. So entropy had been given as the of the thermodynamically reversible process. So this is going to be the ratio between the amount of heat that is absorbed and the absolute temperature. And in this particular case, then therefore we are going to consider this specific ratio for delta S, which is a change in entropy as the ratio between heat absorbed and absolute temperature given as such. So from the two specific equations given, we can be able to have a variation of this Helmholtz free energy given in terms of delta E minus T delta S given as such. And of course, we can do a substitution. This is our equation 1. We can do a substitution for delta S in this case and have a general equation for delta A equals delta E minus T Q reversible over T given as such. So this specific case, we're going to have this element of T cancel out. Therefore, we're going to have an equation, a resulting equation of delta E minus Q reversible given as such. So this specific case, of course, is going to give us the quantity for delta A, which is Helmholtz free energy. Now, if we try to find a relationship between, so let's say this is equation 2. If you try to find a relationship between this specific representation for Helmholtz free energy and, of course, the first law of thermodynamics, we have represented the first law as Q reversible minus the work reversible is equivalent to delta A given in that specific order. Therefore, in trying to rearrange this particular equation, we can have the element of negative work reversible given as delta E minus Q reversible. And of course, in the right-hand side of that specific equation, we're going to have this specific representation. Therefore, we can be able to equate Helmholtz free energy with this specific element of work, and therefore have delta E given as that specific representation for negative work reversible in this specific case. Therefore, the physical implication of this delta A is going to represent the work that is going to be done in this reversible isothermal process, whereby W is going to be that specific or the maximum work that can be obtained from the system. Therefore, from this specific analogy, we can be able to conclude that this element of A is going to be representing what we refer to as the work function, or the maximum work function in that specific, of course, respect. So what of this second element of the Gibbs free energy? So from our representation of the concept of Gibbs free energy, we're going to find out that there's a relationship we have given between the Gibbs free energy and the Helmholtz free energy, whereby we have said that this is basically the addition of the Helmholtz free energy plus P delta V, whereby we had said that this can basically be represented in terms of, or the relationship can be found from the first set of the law of thermodynamics. And then we have said that this is going to represent the work element. So therefore, we do a substitution and find this delta A is the same as negative W plus P delta V, which is going to be represented as such. So in this case, the derivation of the Gibbs free energy then therefore can be represented. So this is delta G using this specific equation. Now we can be able to interpret this particular aspect of the first and the second element of this equation as P delta V as the work of expansion that is going to be performed against external pressure. And of course, the delta G is going to represent the maximum work at constant temperature and the pressure, as we are going to be having it in this particular equation. Therefore, these are the two implications of this particular delta A and delta G, which are Helmholtz and Gibbs free energy in this specific context. So therefore, I'd like to invite our members to check our description boxes for various links of other videos. And of course, this is going to assist us interpret various aspects of the concept of entropy, enthalpy, and perhaps this free energy that we are talking about. So that is it for now, guys. Kindly subscribe to our channels for more and engage us in the comment section for various other links of other videos which are going to assist us have an overall overview of this concept of course, thermochemistry or thermophysics. So that is it for now, guys. Bye. God bless you. Catch us in our next video.